In these next few examples, we're going to determine if two lines are parallel to each other, perpendicular to each other, or neither. In order for us to do that, we're going to go back to the definition of a parallel and perpendicular line. Parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. So let's go ahead and take a look at A14 on page 219. Here they give us line 1, which goes through the point 1, 2, 5, 10, and line 2, which goes through 1, 3, and 7, 15. We want to know of these two lines, which go through these points, whether or not they're parallel, perpendicular, or neither. So what I'm going to do is, for this one particular example, I'm going to go ahead and rewrite the coordinates back down, just so that you can see how I'm using the formula, and I'll only do this for this particular problem. So for line 1, its coordinates are 1, 2, and 5, 10. Right? Let's go ahead and recall the equation of the slope. Remember that it's the change in y divided by the change in x, so that's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So for this particular problem, I usually like to label my coordinates just so that I remember how to plug it into the formula correctly. So you can do that as well. I'm going to go ahead and label this x sub 1, so that's y sub 1. Make this x sub 2, so then this is y sub 2. Okay, now we're ready to plug it into the formula for slope. Okay, so a line that goes through these 2 points is going to have a slope of 10 minus 2 divided by 5 minus 1, which gives us 8 over 4, and that simplifies down to 2. Excellent. Now let's go ahead and take a look at the second line. This line goes through the point 1, 3 and 7, 15. And let's see if this line is parallel to this line, perpendicular, or neither. Okay. Again, I'm going to go ahead and label my coordinates. Make this x sub 1, so that's y sub 1. This will be x sub 2, and so that's y sub 2. And let's go ahead and plug it into the equation. So slope, change in y, 15 minus 3, divided by the change in x, 7 minus 1. So we get 12 over 6, which simplifies down to 2. So note that the slope of both lines is the same. The slope of line 1 is 2, and the slope of line 2 is 2. So this tells us that these two lines, they are parallel to each other. Excellent. Let's move on to the next example. Okay, again, here we have two different lines. Actually, the first line is the same. So L1, we have the same points. Oops, let's go back here. Okay, so let's go ahead and just write down L1 again. Notice that because the coordinates are the same, we're looking at the same line here, and from the last problem we already found out that the slope was 2. So now let's just compare it to line 2. Its coordinates are 1, 3 and 3, 2. Using the formula for slope, that's the change in y over the change in x, so that's 2 minus 3 divided by 3 minus 1. Which gives us negative 1 over 2. Okay, so the slope of the first line is 2, and notice that the slope of the second line is negative 1 over 2, which means that this is the negative reciprocal of this slope here. So because these two slopes are negative reciprocals of each other, we say that these two lines are perpendicular. Excellent. Let's move on to the next example. Okay, again, notice this time, again, L1 is the same. The coordinates are still 1, 2 and 5, 10. However, the second line that we're looking at is the line that goes through 1, 3 and 3, 4. So let's compare these two lines. Again, L1, we already found out from the beginning that the slope was 2. Now let's compare it to this new line, which goes to the point 1, 3 and 3, 4. Again, substituting all the numbers back into the formula for slope, That's 4 minus 3 divided by 3 minus 1, which gives us 4 minus 3 is 1, 3 minus 1 is 2. Okay. Now, if we take a look at this, it almost looks like they're negative reciprocals of each other, except we don't have that negative. So we have positive 2 for L1, but the slope of L2 is positive 1/2. So we say that this is neither parallel nor perpendicular. So we'll say that it's neither. Slopes are not the same. Slopes are not negative reciprocals. Excellent. Let's take a look at the last example. Again, we are given the same first line going through the same point. So let's go ahead and write down the slope of L1 again. And now let's take a look at our new second line, which goes to the point 1, 3 and -5, 15. Okay, plugging this into the formula for slope, that's going to be 15 minus 3 divided by -5 minus 1. So for the numerator, we get 12. For the denominator, we get -6. If we simplify this, we simplify that to -2. So again, if we take a look at the slope of the first line is 2, and the slope of the second line is -2. So even though we have the negative sign here, clearly these are not reciprocals of each other. So again, we would say that these are neither perpendicular nor parallel.